Okay folks, welcome back. It's Nick from DP Brewery Australia, welcoming you to my second Homebrew Wednesday. And as always with me, very rarely released actually on a Wednesday, but we'll try and get close this week. A few things have been happening in the last week or two in the brewery. I had a short trip to Tasmania to help someone set up a brewery. Then back to Melbourne where we've added another tap to the fridge kegerator. And also bought a relatively expensive ice bank stroke temperite, which I want to use to cool one of my stainless steel fermenters, as all the keg space and all the refrigerated space, i.e. kegerators and fridges, are now full. So if I want to do a lager or something that needs some temperature control in a nice hot Australian summer, then this is what I've had to do. Okay folks, let's take a look at what's been happening. My newly delivered cooling system. I call it a temperite, also called an ice bank. Okay guys, so I've obviously got it out of a wooden crate now, and it's looking a bit topsy-turvy because I actually, as I always do with these things, I dismantle them to have a bit of a look to see what's going on. And of course there is actually a pump here. Now, if you can see here, there's an impeller that just keeps the water flowing between, these are the beer inlets and outlets, you can pour in and pour out. And on the outside, of course, the copper is the refrigeration. I don't really see copper from there, but I'll do some close-ups later. And here, this little flat bit on the bottom with a single outlet just here, I'm just pointing out with the screwdriver. That, believe it or not, is an 8 metre pump. I don't believe it goes to 8 metres, but there you are. If it does, it's going to suit my purposes beautifully, because at the moment, I'm not using this as an ice bank. I'm actually using it mainly for this pump, to pump ice cold water around the base of my fermenter in order to cool my ferments down as I go. Okay folks, so just coming in for a little bit of a close-up now on the new unit. Fantastic. It's still sitting on its packing crate and one of my dollars. And at the top here, we're just coming close, and hopefully you can see this. There are 4 beer lines in, 4 beer lines out, all stainless steel. There's a fairly sizable motor on the top, which is driving a pump and an impeller, and an agitator down below to keep the liquid nicely mixed through. The tube you see here was one I had lying around, and by sheer fluke it happens to fit the outlet on the pump. And as we go inside, you can see the outer copper refrigeration pipes, primary refrigeration, and inside the 4 stainless coils for the beer. From the front, it's a very simple unit. There's ventilation on the base and just a single LED to let you know what the temperature is. The ventilation goes all around on 3 sides, and at the back we have our controls, essentially just plug in and a basic manual thermostat. And here, for draining the vessel, a small drain plug. Neat little unit, purchased in Australia. The second stage of the process is that, as I said, I'm using this to cool a fermenter so that I can continue to brew in summer without taking up any more of my fridge space, which has sadly all been turned over to fridges, to kegs and kegerating. So the fermenter we're going to work on today is here, and maybe I'll turn away. This is very much experimental, okay? Because I can't afford to get this professionally jacketed or something like that, I'm experimenting with a lo-fi, I suppose, solution you'd say. And I'm going to wrap a coil of black plastic poly tube. Now, this tube here is 13mm or ½ inch by 25 metres long, and it costs $7.95 Australian. Pretty cheap. And I'm going to wrap this, and with the aid of cable ties, try and make a nice tight blanket around the fermenter. And the idea being that when my temperature sensor, which will replace this thermometer, my PID senses this is getting too warm, it will pump cold liquor, cold water, from our ice bank through this coil. And even though this wouldn't be as efficient as a direct contact with the liquid in a jacket, I still think it should be quite effective. So guys, I'll definitely keep you updated on that. Okay, so what we've done so far is, you can see that I've essentially started wrapping this 25 metres around. I'm going to zoom in a little bit, give a little bit closer look. There we go. Now to start it off, over to the right, just above a leg, you'll see a little bit of tape holding down the bottom of the tube, and so far I've done nothing. I've done no actual fixing. I've just wound it round loosely. See how we go. I'm going to pull it tight now and use some cable ties, so the next time you see it, hopefully I will have finished jacketing the fermenter. So we'll just come out a little. As you can see, it's not the prettiest job in the world, but I think it's going to probably serve our purpose. Now, I've just used standard fittings on the end of here for poly pipe, and I'm going to take these and gradually change them over to fit into just a single 24 volt solenoid. Okay, and the idea being that the pump in the ice bank is perfectly fine to be completely obstructed. In other words, you can just shut it right off and it'll keep working without causing any damage whatsoever. But when the solenoid opens, the hopefully flow of cold water or liquor will find its way around the fermenter. Okay, as I say, not the neatest job in the world, but not bad. Fairly happy with that. Okay folks, well, we're on day 3 of this little project. We've only been doing an hour or so a day. You'll recall yesterday that we wrapped this vessel here in the 23 metres I ended up putting around of black poly tube, half inch, 30mm. And the bit you missed because I forgot to put the camera on is that on top of that I placed some aluminium foil facing in, shiny side in the hope that maybe get another 1 or 2 degrees efficiency. Of course, there's no science involved in that statement, it's pure guesswork and a lot of hope. Thank you, Buddha. Okay, on top of that I've put the insulating jacket that I also normally use on my 60 litre ale brewery from over here, you might have seen in previous videos, and I've popped this on top once again, hopefully to help efficiency. But the big day has arrived. It's haven't even tested this ice bank yet, haven't hooked it up, haven't seen whether the pump actually has enough pressure to push through 25 litres or so of tube. But we're going to put it together today and see what happens. Okay. Okay, another important thing that we need to consider today is that we're coming from the ice bank over to the vessel that we want to cool. Now, this is a bit of an experiment as well. I'm using a sort of $19 Australian solenoid valve and a 24 volt transformer, which in turn will be plugged into one of my PID controllers. So hopefully, whenever the work gets a little bit too warm, the controller will actually open the valve and allow the cold liquor to circulate around the tank. I'm leaving all the labels on because if it doesn't work, of course, I'm going to take it back. Okay, so a little bit of plumbing's happened now. We've got the outlet from the pump in the ice bank coming into the solenoid at this side and running into the base of the coil. I did think about going in reverse, but I don't actually think that will work well. I think there's a tendency then for everything to drain out. I think it needs to fill the coil up to the top and come back out. It's not like a normal jacket that you would get on a manufactured or constructed cooled cylindrical conical vessel. This lead here is coming back. It's just literally another piece of tubing coming from the top of the coil back into the ice bath. So we're now at the point where I'm going to fill it with water, and the first experiment will be without using the solenoid at all, just having it open to see whether the pressure of this pump will fill this coil. We do have a sort of plan B's if this doesn't happen, but we'll just wait and see. Okay folks, so I'm behind the camera just looking at what's been happening. Well, plan A unfortunately did, as they say, go out the window, because it transpires that several issues around the pump here, the internal pump which pumps cold water just very gently up around the font, does not have sufficient pressure to work any sort of standard solenoid valve. Tried all sorts, looked it up, the minimum pressure you really need for a solenoid valve is apparently about 110 kPa. So that's not going to happen. So we're down to plan B. Plan B, unfortunately, means tapping this reservoir from the base, which may present some problems of its own, so that there's a positive pressure on the inlet to one of my circulation pumps over here on the main brewery, and I'm hoping that will give me enough pressure to circulate around the drum and then to return back into the ice bank. To make this work without too many problems, I've had to track down a one-way valve today, and this is what I've tracked down. It's a simple 15mm or half-inch flat valve. In other words, just a very, probably won't be able to see it, but you may be able to hear it. There's a very simple flap in there that allows for one-way direction of fluid and requires very little pressure. So now, instead of a PID controlling a solenoid valve, we're going to have a PID switching a pump on and off. So that's the new attempt, that's plan B. At this stage, folks, I don't have a plan C. So if this doesn't work, it's back to the drawing board, but don't worry, there's no way this little beauty, this little ice bank is ever going to be wasted. Okay, back to work. Okay guys, so heading back into the brewery, I've got the little handheld at the moment just to show you how we've actually ended up fixing this system. Starting over here, of course, we have our ice bank. It's working very well. I'm just going to remove the front cover. Let you see what's going inside here. The inner coil, as I said before, is your 4 beer lines. There's also a outlet which is represented by that shielded hose for doing your font. But what I've actually done now is, just coming around to the back, I don't really want to move it, hopefully you can see this, is that I've inserted a hose in what was the outlet of the ice bank, and by sheer good luck a standard hose connector fitted in there beautifully, and this just goes straight down to the pump. So we're following that black and orange hose over here to the pump, goes through the pump, up through a one-way valve, flow rate this way. It's a simple flat valve, so that when the flap closes, the water cannot go back through the system. In other words, it can't drain from the bottom of the system. From here, it flows through behind the ice bank and has a simple connection here. Flows through, simple connection here, and into the jacket that we made. Round the jacket, outlet just here, outlet coming back behind the fermenter and down into here. And as you'll see, at the moment there's no flow. I'm now going to take out, the whole thing is controlled by this PID. Here we go, where are we? These things never come up well on camera, I don't know why. There we are. It's currently showing 13 degrees on the air, which by the way about 15 minutes ago was 19 degrees. There's no liquid in here. But I'm going to warm the PID up now, and you can see what happens over here in a moment with the... Here we go. So I've now got the sensor for the PID in my hand. Here we go, 15, 16, we've got it set at 17. So 18, the little outlight just came on, which means all things being equal, if we now pull out, sorry, coming out 23, we now pull out the return from the coil, cooling coil, and there we go. Flow. I've also accidentally pulled something else out, which isn't making me best pleased because water's going everywhere. Okay, popping that back so that we don't make too much mess. Fantastic, very happy with that. So folks, that's it for this week. Great to talk to you, and happy Homebrew Wednesday. Cheers. Oh God, you've got to love it, haven't you? I don't know what I'd do if I didn't make beer. Bye.